Hello viewers, in today's class we are going to solve some problems related to increasing and decreasing functions. So here we'll take some conceptual problems, and the first problem is show that the function f of x is equal to 3 over x plus 4 is decreasing for r minus 0. That is, r is the set of real numbers. So the domain is uh, all real numbers excluding 0, right? So here we are given the function f of x is equal to 3 over x plus 4. Now let us differentiate it. So the derivative f prime of x is 3 over x square, and here we have the negative sign, and the derivative of 4 being a constant is 0. Now we know that a function is said to be increasing if the derivative is greater than 0, or the derivative is positive, and it is decreasing if the derivative is less than 0, right? So here what we will do, we see that this x square is a positive quantity, right? And here we have f prime of x is equal to minus 3 over x square. So x is obviously not equal to 0, and x square is greater than 0. So therefore 1 over x square is always greater than 0, and minus 3 over x square is less than 0, and minus 3 over x square is our derivative. So f prime of x is less than 0. So therefore this function is said to be a decreasing function, and the domain or the values of x for which it is decreasing is the set of all real numbers excluding 0, right? Because here we have minus 3 over x square, and x cannot be equal to 0. Now let us take this problem. Find the domain in which this function, that is f of x is equal to x square plus x, is increasing function. So here we have to find the domain, right? So let us differentiate it. So we have f prime of x is 2x plus 1, the derivative of x square is 2x, and the derivative of x is 1. Now in order to be a function, an increasing function, f prime of x must be greater than 0, right? So 2x plus 1 must be greater than 0. So if we solve this inequality, we get 2x greater than minus 1, and x is greater than minus half, right? So if we draw the number line, so here we have the point minus half. So for all x greater than minus half, the function f of x is increasing function. So we can write x belongs to minus half to infinity. This is the interval or the domain in which this function is increasing function, right? Now if we want to find the domain in which this function is decreasing, so what we will do, the derivative f prime of x must be less than 0, and 2x plus 1 is less than 0. So we have 2x is less than minus 1, so x is less than minus half. So here in this interval, that is when x belongs to minus infinity to minus half, in this interval this function is said to be decreasing, and here it is increasing, right? And if we substitute f prime of x equal to 0, that is when the derivative is 0, that is the slope is 0, so f prime of x gives 2x plus 1 is equal to 0, so x is equal to minus half, right? So here x is equal to minus half is said to be the turning point or the critical point. Now let us take this problem. Here we have to prove that this function f of x, x cube minus 3x square plus 3x minus 100 is increasing on r. So what we will do, here we will find the derivative. So the derivative, that is f prime of x, is equal to 3x square minus 6x plus 3, right? The derivative of 100 is 0, so we can now rewrite it as 3x square minus 2x plus 1. Now this can further be written as x minus 1 whole square. Now here we see that the derivative, that is f prime of x, is always a positive quantity because here x minus 1 is a square term and 3 is positive, right? So here for all x belonging to R, this x minus 1 whole square is always greater than or equal to 0, right? So therefore we can write 3 times x minus 1 whole square is greater than 0, and this is f prime of x. So f prime of x is always greater than or equal to 0, right? For all x belonging to the set of real numbers. So here we see that the derivative is a positive quantity for all values of x greater than r. So therefore this function is an increasing function on the set of real numbers. Now let us take this problem. Here we have to prove that the function f of x, that is a quadratic function here, x square minus x plus 1, is neither increasing nor decreasing on this interval, that is the open interval from minus 1 to 1. So here the interval is given as this is minus 1, this is 1, and minus 1 and this 1 are excluded, so we can write here an open circle, right? So now let us differentiate it. So f prime of x is 2x minus 1, right? So the derivative of this function is 2x minus 1, and the critical point or the turning point is obtained by equating the derivative is equal to 0. So f prime of x is 0, so 2x minus 1 is 0, 2x is equal to 1, so x is half. So the value of here the value of x is half, and now we have to show that this function is neither increasing nor decreasing on minus 1 to 1. Now here this derivative can be written as 2 taking 2 common, so we can write it as 2 times x minus half, right? Now let us take this interval, that is x is greater than minus 1 and less than half, right? So when x is greater than minus 1 and less than half, then we see that this term, that is x minus half, is less than 0, right? And multiplying both sides by 2, we get 2 times of x minus half is less than 0, and 2 times of x minus half is our derivative. So f prime of x is less than 0. So when we take the value of x between minus 1 and half, that is this interval, right? Then we see that the derivative is less than 0, right? Now let us take this interval, right? That is x is greater than half but less than 1. Now when x lies between half and 1, then we see that x minus half is greater than 0, and multiplying both sides by 2, we get 2 times of x minus half is greater than 0, and 2 times of x minus half is our derivative. So f prime of x is greater than 0. So viewers, here we see that when x lies between minus 1 and half, then the derivative is less than 0, and when x lies between half and 1, then the derivative is greater than 0. So we conclude that in the interval that is minus 1 to 1, which is the given interval, so the derivative does not have the same sign throughout this interval, right? Because in the interval minus 1 to 1, we see that from minus 1 to half, the derivative has the negative sign, and from half to 1, the derivative has positive sign. So the derivative does not have the same sign throughout this interval, that is from minus 1 to 1. So we claim that fx is neither increasing nor decreasing on this interval, right? Now let us take this problem. Here we have to find the intervals in which this function that is f of x is equal to 6 minus 9x minus x square is increasing and decreasing. Now let us first differentiate this function, that is f prime of x is this is 0 minus 9, and here we have 2x, right? So the derivative is minus 9 minus 2x, and to find out the turning points or the critical points, f prime of x should be equal to 0. So minus 9 minus 2x equal to 0. So minus 9 is equal to 2x, and x is equal to minus 9 by 2, right? Now we'll draw a number line here. So here we have minus infinity, here we have plus infinity, and this is the critical point here, x equal to minus 9 by 2, right? And now we see that the intervals in which this function is increasing or decreasing. So here f prime of x can also be written as, if I take minus 2 common here, then we have x plus 9 by 2, right? So whenever x plus 9 by 2, now x plus 9 by 2 is less than 0. Whenever x plus 9 by 2, this factor is less than 0, that is x is less than minus 9 by 2, then this factor is negative, and here we have already a negative sign, so negative and negative becomes positive. So f prime of x must be greater than 0, right? So what we have done, this is the derivative, and we have expressed f prime of x as minus 2 times x plus 9 by 2, and whenever this factor is less than 0, that is this factor is negative, so here we have a negative sign, and this is negative, so negative and negative becomes positive, so the derivative is greater than 0. So whenever x lies here, that is when x lies in the interval minus infinity to minus 9 by 2, then the function is said to be increasing, right? And whenever x lies from minus 9 by 2 to infinity, then the function is said to be decreasing, right? Because for decreasing, the derivative must be less than 0, and this is possible whenever x plus 9 by 2 factor is greater than 0, that is x should be greater than minus 9 by Now let us take a very interesting problem. So here we have to show that this function, that is f of x is equal to tangent of x, that is 10x, is an increasing function on minus pi by 2 to pi by 2. Now we know that the sign convention of the trigonometric functions, here we have all the trigonometric functions are positive in the first quadrant. In the second, only sine is positive. In the third quadrant, only the tan function, that is tangent function, is positive, and in the fourth quadrant, only cosine function is positive, right? So here we have sine, here we have tangent, and here we have cosine, right? Okay, and here we have all. So here let us find out the derivative. So we have f prime of x, that is the derivative is secant square x, right? And secant square x can be written as 1 over cosine square x, and here the interval is given as minus pi by 2 to pi by 2. So here we have 0 and 2 pi, and here we have pi by 2, here we have pi, here we have 3 pi by 2. Now here the interval is given as x belongs to minus pi by 2 to pi by 2, and the derivative is given as 1 over cosine square x. So we see that obviously because here we have minus pi by 2, and whenever x lies from minus pi by 2 to pi by 2, so the value of x lies in the first quadrant or the fourth quadrant, right? And in the first quadrant and fourth quadrant, cosine function is always positive, right? And moreover, here we have the term, the square term, that is cos square x. So 1 over cos square x is always greater than whenever x belongs to this interval, right? So therefore the derivative, that is f prime of x, is always greater than 0 whenever x belongs to this interval, that is minus pi by 2 to pi by 2. Hence we can conclude that the function f of x, that is tan x, is an increasing function on this interval.